everyone, my name is Aditya Bhalla, and this is my major project for EECS1011. So for the introduction, I'm basically taking the Arduino Grove Board to identify and examine C system code in MATLAB to perform the specific task from my technical widget, which is, again, to act as an emergency alarm system when it's connected to the specific pins on the Grove Board to be able to A, light LEDs that are moving back and forth as a sequence, B, playing a sound through the buzzer, and C, the direct component fans to run continuously. And to turn off the technical widget, you just press and hold the push button. So to reintroduce what I just said earlier, I'm using the Arduino Grove Board and other electrical circuit elements to connect them to the technical widget, where I will use my C system code and run it through MATLAB to create a background LED flashing / buzzing alarm system with DC fans running through this process. Why I'm doing this is because I want to understand how the Arduino Grove Board works, and it must be able to perform the specific function that I have chosen. In order for the technical widget to function correctly, all circuit components and electrical devices must be connected together, for which the technical widget must be able to A, flash LEDs in a sequence which will be moving back and forth, B, generate buzzing noise while LEDs are flashing, C, allow fans to run as LEDs and buzzers are active, D, continuously play a background flashing LEDs / buzzing alarm with fans, and finally E, it must contain a push button to completely stop all actions at once. So for the components list, we have an Arduino Grove Board, a full-size breadboard, wires, a 10 kilo ohm resistor, a blue LED, a red LED, a push button, an active buzzer, a physio buzzer that's on the Grove Board, a red LED that's also on the Grove Board, direct component 5-volt fans, and a 10 feet micro USB to USB Type A cable. So in the procedure, we're going to create the C system code from MATLAB to perform the LED flashing / buzzing sound with fans, basically the emergency alarm system. And then we're going to create the technical widget corresponding to the task using the Arduino Grove Board and other circuit elements, and then connect the technical widget to the computer using the Arduino Grove Board to see if it works. And then in the next remaining slides, we will explain the in-depth knowledge of my strategy. So for the first part of my strategy for my C code, I define a function to call on two variables. The first being the Grove Board, which will establish a connection from MATLAB to the Arduino Grove Board, and the button variable, which will basically set to false. Then I define the specific port pin registers using the digital write pin command, where D6 is the buzzer, D2 is the button, D3 and 4 are the DC component fans. Next, we have the while loop with the condition that if the button is not equal to true, then the two for loops will occur. These for loops will have the number to str command, which will convert the number of iterations into letters of specific pins / ports that we will define as LEDs as D8 to D13. So the for loops will basically turn on and off the LEDs and buzzers at a specific time delay of 0.001 seconds, while the DC fans will remain on, and this process will repeat on for a specific number of times, which will cause the LEDs to move forward and backwards, basically turning on and off in a sequence. And then finally, to exit or stop the code, simply press the push button to have the loop condition hold true so that it basically stops the technical widget. Once again, we have the MATLAB code in the form of a flowchart. So basically, when we start the code, we define the connection between the compiler and the Arduino Grove Board. Then we define the port pin registers associated with the Arduino Grove Board and the push button value set to false. From the while loop, if the button is false, the two for loops will run, and every for loop will define the port pin registers for the LEDs, which we use the number to str command to convert the ranges of X values to the specific port pins D8 to D13 in the Arduino Grove Board. Now we define the remaining port pin registers D3 to D6 to be on for a specific time frame of 0.01 seconds, and then for all port pin registers to turn off, and as the condition of the while loop will hold true, the for loop will allow the technical widget to continuously flash LEDs back and forth with fans and buzzers running until the push button is pressed to turn off the technical widget completely. This is a process in which we show the wiring process of all the circuit elements connected from the Arduino Grove Board to the breadboard. For the last part, I will run the MATLAB code for which the Arduino Grove Board will recognize specific port pin registers connected to the certain input-output hardware, which will perform the specific task shown in the next slide.
So as you can see, the LEDs are flashing forwards and backward direction. The active buzzer is playing the sound. Same thing you can see here with the physio buzzer if I like. And then finally, you can see two DC component fans running simultaneously. And now for the final test. Everything stops.
So the technical widget is able to perform all system specifications, and here I have two graphs that represents the following test. The first test represents the technical widget being on for a short period of time, and the second test represents the technical widget being on for a longer period of time, based on the amount of voltage emitted per time. Here is my contingency plan for what I have done. Here are some of the lessons learned related to H4000. Here's how my technical widget can satisfy the social, political, environmental aspects. And here's my conclusion. Thank you for watching.